Hi, today we're here with Brian Patrick, our VP of Engineering, and we want to answer the question of how is our equipment optimized around the needs of our high volume 24/7 operation type of customers. Brian, what makes our equipment robust?
So starting off, we start off with our base, and our base is our frame, and we pick materials that are very strong. We do a welded configuration for this, and we build up from there. So our base is the starting point, and we make sure that that is the strongest point of our machine. We also use heavy gauge materials and everything that's built off the machine. So as we were putting in bracketry, as we were putting in conveyance, we were making sure that that gauge of material is also very sturdy and set up very well for the long term of 24/7 operations. Further to that, we pick the components based on our design needs, plus a safety factor. So we're not only just picking the components we need, we're thinking about what it takes to go 150% of what it would normally run.
Okay. In design considerations, when we design our machines, what are you thinking of to make sure that it runs 24/7?
Sure.
All the time.
So nice thing is we start off with a rich history here. So we have a lot of base data for machines that are already in the field running at that rate. And we build from there. We take that data, we use tools nowadays in our emulation and our modeling software to where we can then put that kind of information in and build on it into the future. So our new machines and our new cells and things are using these high technology tools based on what we already know from years of history of what we have designed and have in-house.
So we use that technology for all of our robotics, for all of our packers, for our palletizers. Every application that comes through, we use emulation.
Correct.
Explain a little bit more what that is and how you guys are using it.
Sure. What emulation does is it allows us to create the equipment in the digital world. It's a physics engine, and it allows us to take everything that we know about the machine and about the application and put it together and kind of look ahead before we actually have the machine in operation. So we can predetermine how it's going to perform in the field before it gets there.
So you basically test in the virtual world?
Test it in the virtual world.
How close is it to the reality? Like when you actually have the machine on the floor, is it truly like 100% the same?
We've had very good results with the engine. In fact, we kid around because sometimes the engine is very realistic, and when we simulate, we throw a product on the floor, and so we know kind of what the first version of this stuff is going to be, and we're able to kind of preemptively decide if we've got the right designs or not before it gets there. So that helps us get ahead of the curve, helps us understand kind of what we're going to see in the field, and so prepares us pretty well for what we're looking for.
Right. What kind of advanced features do we build into machines that are standard so that our customers have a very good experience with the machines? Again, in a 24/7 high volume operation, that's a lot more demanding than if you have just one shift.
Sure. So first off, we start with kind of the machines are built on the whole concept of the user-centric design. And what that means is not just what you see on the screen. It's everything that you see in front of you. We've gone through and taken data from actual users. We use that in what we put into the machine. So from the operations of how you make the adjustments, how fast the machine can be turned over, to how they would drive the dialogue on the screen to help the users understand what the next steps are to set up the machines. All of that goes into play into helping them keep that situation running over and over again. Also, our equipment is set up for remote support. So not only is it just built to run, but if something should happen, we have the ability to jump in at any time and make sure that we can keep the operations going.
I also know we have Cat 3 as standard. We have lighting, additional lighting inside the machine, also colored lighting that is standard. We have the LED beacon that is always standard. We just want to make sure that the customer can run their machine. They get the notifications that they need.
Yes. We provide the feedback on the machine in a lot of different ways. And so they can see, not even just that necessarily standing next to the machine, we make our machines pretty pronounced so that an operator downstream of the operation or upstream of the operation can see kind of what's going on and know exactly what the situation is and when they should react to the machine. So from giving pre-warnings that a material is going low to something's actually happened and then it needs, somebody to interact with it.
What is the engineering, like the iterations of the machines? Do you do like a yearly review, and what are new features that we have to include?
So yes, we look at the machines year on year. We also look to see kind of what technologies are in the market and anything that we can take advantage of that would make sense to bring into our equipment that would help us further this goal of making the machines very easy to use and run in a 24/7 operation.
What's an example of what we have included as of lately so that the machine just kind of keeps advancing?
So one of the things let's say a couple things. We look at kind of remote technologies that sit out there, and one of the things that's probably helped us the most is we're putting on technology now that allows us to, in the future, help with predictive maintenance. So we have the ability to add onto these machines with smart technology. Gives us the ability to, again, collect more data, help troubleshoot, help further design. We see things that we can preemptively put into the next revision of the machine coming up in the next year. Those kind of things are what we're looking for as time goes on.
So we're really looking forward to predictive maintenance as sort of that next step. How far out is that?
You know what? The technology is here today. The next step is really kind of just getting the user world out there and excited about it and kind of saying, yeah, I want that on the machine, and I want, we have predictive maintenance in the plant, and we understand that the machines are getting smarter, and we want to take advantage of that too.
So what's the obstacle?
Obstacle is just merely getting it out to the world and being able to use it. We need the customers to kind of buy into that too and say, yeah, that's definitely something that the machines need to have. We want that because we want to be able to see our machines ahead of time and not wait until the machine breaks down and then fix it.
Okay. So if the customer is interested in having that, we want to have the conversation, and you or your team is more than happy to jump on a call and have those conversations.
Absolutely.
Okay. Well, thank you for the conversation.